Hey guys, welcome to this lesson. So in this class today, we'll be looking at tool use, which is chapter 4. Remember in chapter 3, we looked at UX design pattern, and then I believe you learned a lot in that lesson. So here, we're going to be looking at tool use in agentic system design. So how do you choose tool? How do you know which tool to use, and how do you program your tool into your system? So definition and importance. So let's first look at what tool use is. So tool extend AI agent beyond text generation. Okay, so you don't agents are not just like LLM that will generate text or generate picture or generate video. No, they can do many things strategically or based on what you decide them to do, or based on the rule that you put into them, based on the logic and the problem you design them to solve. So tools is very important if you want your agents to be dynamic, if you want your agents to be advanced, to be able to solve advanced problem. So tool extend AI agent beyond text generation, allowing them to retrieve information. It allows them to retrieve information, it allows them to perform tasks. It also allowed them to interact with the environment. Okay, so just like you as a human being can interact with different people, agent can also interact with other agents. They can also interact with other web APIs, okay, through what we call tools. So like human professionals, agents need a lot of tools for effectiveness. So be like we human, before you can solve problem, particularly in the enterprise, you go through university, you get MBA, you get MSc, BSc, and whatever. After that, you still have to do some professional courses before you can begin to solve large scale problem like enterprise or scale problem. So also for agents, they need a lot of tools, they need a lot of professional tools to work. These tools are not just like they are not just ordinary code, they are Python functions. Just like we have mathematical functions or mathematical operators that can solve so many problems based on their performance, or based on their design pattern. So also tools of AI, they can do many things based on what you design them to do. So they range from simple calculation. What they can do range from simple calculation to complex multi-step enterprise operations. So if you program these tools into your AI, it enables them to do multiple things at the same time, which makes them advanced and be able to solve a large scale problem or hard problems. So we have so many type of tools that we can see here. So we are going to be looking at the type of tools that we have. So they are not in this chart. So we have local tools. So local tools enable your AI agents to interact with your local applications, like your local database, or like your like application installed on your laptop or desktop, or calling, interacting with your calendar, with your Gmail, and so on and so forth. So local tools run on agent environment, and they are precise. Local tools are precise, they are predictable, and they are ideal for operation like math, date time manipulation, and to map queries. So the drawback include maintenance. So you may not be able to maintain local tools or duplicate them or extend them to other applications. So we also have another kind of tool. We have a remember type, we have local tool, we have API tools. So API tools connect agents to external services. So these tools, API tools, act like this. You have your tool here, then they connect agent to external services. So maybe you have your web, you have your let's say your other applications that you have here. You have your database, for instance, somewhere on the cloud. or maybe you have other system that you want to connect to, and so on and so forth. Or maybe you have your drive or your Google Drive. So this is the API tool. So it allows the agent to interact with external services, enabling real-time database access, and it also enables the agent to perform complex computation, okay? Complex computation and integration with diverse systems. You can integrate with a lot of systems. So this particular characteristic for this one is that they are very reliable. API 2 are very reliable. Okay, they are better than local 2. They are very security. Okay. And then when you are designing them, you must, implement error handling. So implement error handling. So these things here are very critical. So put them into consideration when you are designing API 2. Very, very important. Make sure your tools are reliable. Make sure they are very secure. Make sure you implement, error handling. So security, you can put guardrail on the API to prevent, external access or prompt injection. So another tool we have is called plugin tools. So we have plugin tools. So plugin. These are pre-built modules from platforms like OpenAI, Anthropic, Google, and Microsoft or LangChain, allowing rapid integration and scaling. So these tools allow rapid integration. So you don't need to design, you just use them. Rapid integration with systems. Okay, it also allows scaling or scalability. So based on your platform, and then they trade customizable for ease development. So instead of the problem with this one is you cannot customize them. It's only allow you for easy use. You can easily use it, but you cannot customize it because it is pre-built. They are just plugins. You just plug them into your agent and use them. Then another tool we have is called the MCP. Okay, MCP. Remember MCP server, which is very popular now. The meaning is M stands for model, C stands for context, and P stands for protocol. Okay. So MCP server tools these are standardized model agnostic interface for connecting agent to external system like JSON RPC, enabling reusable modular tools across agents. So they are very standard. How it works is you have the server and then you have your client. So you have the server which will process all the information. You have the client that will interact with all the APIs to get information. So these tools are combined together to form what we call the MCP tools protocol. So we will still look at it in detail, how to program your server and your client, which is often the powerhouse of most agentic systems out there like Claude. So tool management is also important. You must be able to manage your tools interacting with persistent data carry risk of destructive action or exploitation. So you must make sure that you implement guardrail into your tool. So best practices include narrowly scope operation, input validation, least privilege. Make sure you practice minimization and anonymization of data. Implement role-based access control and put guardrails and logging where necessary. Also make sure you implement monitoring and auditing, so to make sure that your tools are very secure. So automated tool development. So agent can generate their own tools. We are going to see how this works very soon, using foundation models, producing code stub, helper function, and atomic operation. So we have agent, we have real-time agent code generation. So agent write and execute code on the fly and address tasks with new APIs. So the agents that we have out there now can now generate their own tools. Like, you don't need to pre-build tools into them. They just think and and figure out which tools they need, and then they program it immediately on their own, and then solve the problem. You understand? So this actually moving toward what we call the artificial general intelligence. So to use configuration and robustness, agents can be configured to call tools flexibly using automatic development, that's deterministically, or require or not at all. So agents can be dynamic. They can call tools and implement tools on their own. So you have in this diagram we have a kind of tool registry here, centralized track, safe, production ready. We have these two. We have file system tools. This one allow the agent to read file, write file, append file, and check existence. We have this database tool. This enable the agent to pass JSON format JSON, and protection, security protection. It's very important. Security SHA 256 hash to secure everything that is going to the database or coming from the database, and count length, so using a kind of SQL query. Then we have network 2, so allow the agent to pass HTTP request simulator, so simulate HTTP calls, okay, file request. And then we have another to unify result wrapping. So these two return calls, two results, success, output, error, timing, and metadata. So this is what you have as the output, and we have the system too, which allow the agent to interact with its CLI, safe shell, whitelist-based, and common execution. So this is how the architecture of Tool Registry normally look like. You understand? So this is what the architecture normally look like, and this is what you have there. And then build production. Okay, so Tool Registry, result wrapping, tool category, safety first. Remember, make sure you put safety first in whatever you are designing. So now let's go into our code and look at how tool use actually work in action. So tool use comprehensive tool integration. So here we have what we've discussed, what we are going to cover, which is Tool Registry, and we've seen Tool Registry in our diagram. So Tool Registry, central registry, we start and login part 2. Result wrapping, every call return to result, success flag, output, and timing. Then we have two categories, that's file system, data system, network, grouping by purpose. So these are the example of tools that we have in this problem that we are trying to solve here. Safety, whitelist-based shell execution. So it's also very important. Put it into consideration. So this is what we are going to cover as we have seen in our architecture. So this is what the architecture look like here. So from the topmost part, we have the agent orchestrator, we have the tool selection here. So this is what allow the agent to select tool, and then we have the various tools that you can select. We have file operation. So under file operation, we have what the file operation tools will do: read file, write file, append file, check existence. And then we have the data processor tool, which will pass JSON, format JSON, or secure the data by encrypting the data, encrypt what is going into and what is coming out of the data, and then determine the current length. And then we have the other two here, which is safe shell, okay, whitelist validation. So it allows the agent to check what is going into the system and what is coming out. So this is just like the security tool, whitelist validation. If it is allowed, it will send it to the result. If it is blocked, then it will reject it and send this reject dangerous commands to the system. So this is guardrails, very, very important, very, very important. So HTTP request simulator, we have the network layers which simulate HTTP get, HTTP post, and mock API response, and all this is routed to the to where we have the tool result. So this is the tool result, and this is the output finally to the user, which is the agent response. So this is how tool integration works. Alright, so let's go into our coding. So we are going to import our modules as usual, and then let's run. We are using Python 3.14.5, almost the latest one, so let's wait for it a while. So it's our modules are imported. So step 1, tool data model. So tool result, every tool call return a tool result, which is a uniform envelope that always includes success, that's did it work, did the tool work, output, the actual result of the tool, can be any type based on what the tool is configured to do, based on the function of the tool. Remember, we said a tool has 3 properties. A tool must have a name, it must have description, and it must have a function. That is the problem it is designed to solve. Okay, remember, before you start designing an agent, you must have a problem you want to solve. So we have error, can return error if error message if failed, and we have execution time, that is how long it took for the tool to complete the task. And the uniform result means the agent's calling code never needs to handle raw exceptions. Okay, so two definitions, very, very important. Metadata about the tool, its name, the callable, a description for routing, parameter schema, category, and whether it needs authorization. Okay, so we are going to define our tool class here using data class. Our data class, class tool result, success bool, output, earning, error, string, execution time, float, metadata, string. Okay, so we have all of this designed already, and then we have data class two definition. We have two data class, two result, and two definition. So class two definition, name, string, function, callable, description, parameter, which is dictionary, string, and it can be any, category, general, require authorization, boolean, false. It doesn't require. So step 2, we have defined the two result and two definition using a data class. Remember, you can also use a dictionary for this, but we have decided to use a data class, which is better. So Tool Registry. Tool Registry is a service layer that wrap every tool to call with existence check, try except wrapper, which is error handling, start tracking, and execution log. So Tool Registry is a service layer that wrap every tool call with the following: existence check, fail fast if tool doesn't exist, try except wrapper, never lets a tool crash the agent. So this function here will never allow a tool to crash your agent. Start tracking, call count, success or failure per tool, success rate and failure rate, execution log, timestamp and audit trail, and everything, the log about how the tools work and how it interacts with the agent. So the agent never calls tools directly, it always goes through the registry. So another way to protect your agent is never to allow it to call the tool directly, but let it go through the registry, the Tool Registry class, to get a tool. Okay, so this also allow agentic performance in design principle. So class Tool Registry dev init. So we initialize the Tool Registry with self.tools, self.execution log, self.tool start, and then you register the tool, self.tool, tool.name tool, self.tool start, tool.name, calls, success. So these are the statistics we want to return: success and failure, calls, success and failure rate. Those are what we want to return. Then define the execution method. Def execute string. If name not in self.to, return to result false. None, to name not formed. That is, the tool is not formed. Then to self.to, start time, time.time, and self.to statistic. Return the two statistic. So then remember, put exception handling, so that if 2 does not exist, your agent will not crash. So result equals to 2.function quarks elapsed time.time minus start time, self.to start success, self.execution log.append. You have the 2 success and time elapsed, time start and everything. Return 2 results, true, result execution time elapsed, except exception as e, elapsed time equals to time.time minus start, and self.time start time, name failure equals to 1, return 2 results, false, none, and elapsed. So this allowed the agent to use exception handling to carry out operation when the 2 does not exist or when there's a 2 crash, so that the agent will still perform normally. And then the last method, return the statistic of the 2, get start. And so let's just run this function to see. So it has run successfully. So we have successfully defined the Tool Registry class, and we've initialized it, and we have the method, okay, register to, execute to, and return and get to statistics. 2 implementations. So 4 tools covering different capability category. Remember, we have 4 tools according to our architecture here. We have the file operation 1, data processor 2, and then we have the safe shell 2, which is 3, and then the last one is HTTP request. So those are the 4 tools we have there. So the file operations implement file system, unify file tools, read, write, append, check, and so on, which we have gone through. Data processing, get and send data and retrieve data from the database in JSON format. It passes JSON, format JSON, and encrypt the data using SHA-256 algorithm, and then count length of the data. Safe shell, that's system guardrail, okay, protect the system, passes the interaction through a safe shell to check whether it is safe or not. Execute shell command, but only from a whitelist. So only the whitelisted information will be executed, then critical one will be rejected. So the agent cannot run arbitrary shell command like rm minus rf. So this allows the system to detect a prompt injection and then reject them immediately. HTTP request with simulator network. So simulate HTTP calls like get, post, delete, update, and so on and so forth. In production, this will be HTTPX or request. Okay, so this is our 2 definition and implementation. So we have 4 tools. We are going to define them. Remember, tools are Python functions designed to solve problem. So file operation is programmed to do what we design it to do. The file operation, if file operation is read, it will open the file and read it. If it is write, it will open the file and write to it. If it is append, it will open the file and append text to it. If the operation is to check whether file exists, it will return whether the file exists or not. If it does not, if any of this operation if any other operation is passed into the tool apart from this operation 1, 2, 3, 4, it will return unknown. Remember, this file operation is programmed to only read, write, append, and check whether the file exists. So if any operation is not defined here, it's going to return unknown. Then the second tool, data processor 2. So the operation is to, pass and format data. Okay, data. So if operation is JSON pass, it will return JSON load data. If operation is JSON format, it will return JSON dot. It will dump the, JSON data into the database. JSON.dump, JSON.load data. Okay, so if the operation is to hash the data, that's encrypt the data, it will pass SHA 256 and encode whatever it's in the database. Then if the operation is length, it will return the length of the data. And if any other operation is not part of this for, it will return none. Okay. Then safe shell operation. Remember, this is guardrail. Only command in the whitelist are allowed. Prevent command injection. So safe prefixes. So this one will be whitelist as safe. ls echo cat print. So ls, that is list current working directory. Echo, that is print. Cat, that is to also output something. Print working directory, that's pwd date. Who am I, to check who is working currently. So cmd start command dot strip dot split 0. If cmd start not in safe prefixes, return f command. cmd start not in whitelist, try result subprocess dot run command shell true, capture output true, test true, timeout timeout. So return result dot std out plus std dot stder error. So except subprocess dot timeout, return command timeout after the timeout. Except exception as e, return f error. So def http request simulator method url data pass into dictionary, then it will return the following method url status 200. So this is the http request, and the method it's using is method. We have the url, we have the data. So get method response will be simulate response data timestamp date time dot now dot iso format. So these are all the two definition, and that is how they also work. So we have run them and they run. Then after our two definition and implementation function, we have the register and run the tools. The next step is to register and run the tools. So registry, remember we've defined the two registry class above. So register all these tools that we have defined, the 4 of them, and this is the registration. Registry does register to definition, file ops, file operators, file operation. Remember, register the name, register the description, and the function. Okay, we have the name, file operation, we have the description here, read, write, append, we have the function here. Then to definition or data process, the name is registered, the description is registered, the function is registered. We have shell, the name is safe shell, this is the description, and this is the function. Then we have http, the name is http request simulator, register the description and the function. So our tools, this is the script to register our tool, and then we are going to run that. So something happened, name to definition is not found. So we have not defined our to definition somewhere. Okay, def register to definition file up. So let's see if we have not run. We have two registry, and we have class 2 definition. Okay, let's run this class. Let's run this again. Let's run this again, and let's now run this. Okay, good. So I think so if it's happened, just go to the to definition class, go back to step. If it's happened in your end, just go back to step where we define the step 1, and we run the data class to definition, so it will start working. All right, so we've run our to definition, and all our tools, as you can see, they are registered. Okay, and then test. Let's test the two, test the 4 of them. These are their functions: shell, function, data process, function, data process as well, JSON format, key value, HTTP, get this HTTP, and shell block this one. So let's run, let's see if they'll perform their function, and of course they actually worked. So param command echo hello from agent 2, success true, hello from agent 2, output. So the shell 2 was able to validate this echo hello from agent 2, and then it returned the output because it is safe, the content is safe. So data process, operation hash data test data. So output true, and it was able to hash the data. This is the hashing. Okay, it has hashed all the data in the database, and this is the time it takes. Then data process, operation JSON format data key value num42. So success 2, the 2 works. This is the output. Remember, it passes the data as JSON. See the JSON output, see what we pass into it, and look at the JSON output here, and this is the time. So HTTP method get this URL, get the content of this URL. So success, did the 2 work? Yes, true. Then the output, get the URL, the status 200. So the URL is okay, and this is the response. This is what is in the URL, simulated response, data none. So because this is just a dummy URL. Then to shell param command, pass this command into the shell 2, success true, output command rm not in whitelist. So it is not part of the whitelisted command. Remember, we whitelisted some command like ls, pwd, print working directory, and so on, but this is not there, so it is not in the whitelisted, so it will not go beyond that. So, and then Tool Registry, let's run our Tool Registry, and then we have 4 tools. This is our tool statistic, data processing, shell, and everything. So this is how you define a tool, and this is how you test a tool. So in just how many steps we have implement tool operation. So the concept we have looked at here is ToolResult envelope. Every call is wrapped, no raw exception, reach the agent. Tool registry, central hub where the agent call tools to use, register, execute, log, start. It follow this design pattern. Then require authorization flag, foundation for future authorization middleware, and the shell whitelist, safety first, deny by default, allow specific command. So this is how tool operation, how you define tool integration in agentic system design. So in later chapter we'll be getting, we are still laying the foundation. So in our latest chapter we'll be using API key, and then we are going to implement this in real life. But actually this is how you define tools following the simple steps. Tool data model, define your data model, define the tool registry class to register all your tools, and tool implementation, define the tool, their name, their function, and their descriptions, and then register the tool in your registry, and then test the tool to check if it's functioning, and then get your tool statistic. Remember, monitoring and observability is also very, very important in agentic system design. So this is our overall code here, combined if you are building for production. And if we run everything together here, you can see we still have our output or the way we have it in our notebook, and we have all the steps implemented. First step, import module, define your data class. Second step, register your tool. Third step, and then the next step is tool implementation, where we define the name of the tool, the function of the tool, and the description, and we have 4 of them here. And then we have the register the tool, and then we register the 4 of them, and then test the tool with some queries, and then we show the statistic of the tool, and everything as we know it works. So this is the end of this class. Hope you have learned a lot. please subscribe and like, and tell someone to also tell someone to also tell someone to subscribe, to like, and to watch all the video. Thank you everyone. See you in the next lesson.